Well, here we are, finishing up our copper and silver nitrate lab. Wanted to show you what the silver looks like. Hopefully you can see it's kind of sparkly. Also, I want you to notice that there's green a little bit, not too bad. I did a pretty good job on filtering. There's a little bit of green on the edges of the filter paper, but we're gonna get our final mass now. And looks like 0.97. So one of the things I forgot to do is measure the mass of the filter paper last time. So hopefully this will all make sense. You should have a copy of the lab. I'm not going to make you do all the pre-lab questions, but I do want to talk about them a little bit. So this was a lab to get you more acquainted with moles and molar mass and all that stuff. Remind you about single replacement reactions, which I just gave away one of the answers. Talk a little bit about molarity, and then also look at limiting and excess reactants, percent yield, and the like. So the first pre-lab question is to write the balanced equation for solid copper with aqueous silver nitrate to produce solid silver and aqueous copper nitrate. So I always just go in order. Solid copper, aqueous silver nitrate, produce solid silver, and aqueous copper. Two important piece of information, nitrate. So we need two nitrates with this to balance it. It's charged, get charged to 0. So probably pretty quick, you can see I have one nitrate on this side and two on this side, so I'm going to need 2 of these. That means I'm going to get 2 silvers as well. And then the coppers and copper nitrates are 1. So I've already given you the answer for this one. It's a single replacement reaction. Molarity we haven't talked about a super lot, but let me just remind you, molarity is kind of a weird capital italicized M is its abbreviation. And this is a way to measure concentration of solutions. It's the number of moles of solute per liter of final solution. So chapter 16 is all about solutions. We might not get too much of that done this year. A solution has a solute and a solvent. Remember, solutions are homogeneous mixtures. We typically think of them, the solute being a solid and the solvent being a liquid. It doesn't have to be that way. Could just be the lesser amount and the greater amount, but they add together to make, solution. All right, so molarity is concentration, and you get that again by number of moles per number of liters, and it's abbreviated with this weird kind of capital M italicized. A ratio, you guys know, is a way to compare things. It's a fraction. That's the easiest definition. I'm not doing complete sentences, forgive me. Molar mass of copper, if you look on the periodic table, get around to the hundredths place, so 63.55 grams per mole. Silver is 107.868, so we're just going to round it to 0.9 because that's already 4 sig figs grams per mole. And then to get the mass of silver nitrate, we need the mass of a mole of silver atoms, the mass of a mole of nitrogen atoms, and the mass of 3 moles, 3 times 16 oxygens, and that gives us 169. I'm just going to again round to 4 sig figs, so 169.9 grams per mole. Okay. To figure out how many moles of silver nitrate are in 50 milliliters, a couple of things has to happen. The milliliters have to get changed into liters, so we have to divide by 1,000. And then molar solution, that's how we say it. We say 0.2 molar, this capital M thing. And that when we rearrange this equation, which we haven't done yet, so let me do that. So the two pieces of information you know are the concentration and you know the volume. So if this is a three-part equation, number of moles is simply equal to molarity times your volume. Okay, so when you take 0.005 times 0.2, oh, wait, I got an extra zero in there, didn't I? Who caught that? Is that right? There we go. At 0.050 times 0.2, you're going to get 0.01, and we can throw on another zero because it's significant. We could actually put on the second one. Moles would be present, and changing grams into moles, you should be able to do that pretty easily, and changing moles into atoms, you should be able to do that. So I'm going to ask you to just fill these in, and then the calculations on the pre-lab part, I'm just going to ask you to do 9 through 14. I'll specify that in the instructions. So I'll leave this for you to do on your own piece of paper. Remember, if you've got grams, you're going to have to divide by the molar mass. If you have, once you have moles, then you can change them into atoms by multiplying by 6.02 times 10 to the 23rd. All right, so this is the instructions for the lab you didn't do. If you watched the other video, which a lot of you haven't, you saw copper wire, which is copper colored, of course, and solid. And you also saw a clear, colorless liquid. Looked pretty much like water. There are actually a little few black specks in silver nitrate. Sometimes it does precipitate out. So this was at the beginning, the second day, quote unquote, that was after a couple hours have passed. You can see that there was silver dangling off the wire, silver clumps on the wire. It's really cool looking. I hope you watch the video. And you can actually see some sparkles on it. So silver colored, we have to be careful because we didn't test it. It was really silver, but it is. And then now the liquid is clear, but it's not colorless anymore. It's a light blue color. And then again, today's solid silver has some sparkles to it. You can actually, you probably can't see it on my phone video, but you can actually see little little needles of the crystals. And then again, there is some blue tinging on the top. Not too bad, but there is some blue tinge on the filter paper. Silver, crystals, and slight amount of blue on filter paper. Okay, so the volume we used, I got really lucky. It was exactly 30 milliliters of the silver nitrate. And the data from before, as you know, the mass of the wire after was 0.79. The mass, excuse me, that was before, the first day, and then it was 0.72. So the difference between those is how much copper was quote unquote lost or used. It was 0.07 grams. Filter paper, I forgot to mention on the video, the filter paper by itself weighs 0.70 grams. Today, as you saw, we got 0.97 grams. That means there's 0.27 grams of silver on that filter paper. So to convert 0.07 grams and 0.2, whoops, did I do my math right? Yeah, 27 grams. We take 1 mole of copper, 63.55, and 1 mole of silver, 107.9, and do the math. I'll leave that for you. And again, to get the atoms, once you've got the number of moles, you just simply multiply by 6.02. So you take this answer, put it here, times 10 to the 23rd atoms per 1 mole. This answer goes here, moles of silver. So from the balance equation, which was over here, there's 2 silvers for every 1 copper. And you know that you can set it up as a fraction. You could do it like this with the colon, how we like. You're going to take your moles up here and put them here and here. So you're going to make a fraction again, moles of silver to moles of copper, and get your answer for your ratio. Remember when you get numbers like 0.25, because you're going to get a decimal here, you know that 0.25 is a quarter. The one on the bottom is considered 1, so this would be a 1 to 4 ratio, for example, okay? So that's something just to keep in mind when you get your answer here. The, where am I? Next one is taking atoms. So the second part, you're gonna use these top 2 for number 2. You're gonna use the second 2 for number 3. And then using our formula for molarity, moles per liter, change the milliliters. Remember we had 30 milliliters, change that to liters. And the concentration is 0.10. So figure out how many moles of silver were available. There's 1 mole of silver in every mole of silver nitrate. And then you're going to use the answer from number 4 as your denominator. You're going to use your answer, well, technically here, this answer as the numerator, and see how your ratio comes out compared to the rest. I'm gonna ask you just to write just a couple of sentences. I'd just like you to answer this. Did you really make silver? Did the copper really disappear? Okay, don't worry about going through the whole purpose thing. Don't worry about stating your data. Do think about where I could have made a mistake and not pushing buttons on my calculator. That's human error. Okay, and then yeah, go ahead and state your percent yield that you got. Okay, so did you really make silver? No. Did you really have the copper disappear? No. Where did possible boo-boos happen? Okay, and where would they most likely happen? And then maybe, okay, just think about how you would improve it. So 4 or 5 sentences, that's all you need. Don't worry about going through all this, okay? All right, and I'll just tell you that the current price of silver makes this amount of silver worth about less than a penny. Okay, so it's really not very much. It looks all cool and beautiful and sparkly and shiny, and I do recover it every year. See all the sparkles? But it's really not worth that much, and it's really fluffy. It's like a powder. It's pretty neat. All right, hope you're all well. Take care.